Alrighty, here we go. So, like I said, we're going to be reviewing here today. Okay, looking at our review. Okay, so we've covered a little bit of ground here. Not nearly as much ground, I think, as we did for the last test, but still, stuff we need to know. Okay, so first thing we're going to write down here is the quadratic formula. Okay, now, do you need to have the quadratic formula memorized for your test tomorrow? No. It will be given to you on your test, but we're going to write it out just because. Okay, so x equals negative b plus or minus the square root b squared minus 4 times a times c. Okay. All over, I'm going to use this bar as a fraction bar here, all over 2a. Yep. You don't have to put parentheses for the a if you don't want to, but there it is. Okay. Now I know Sky knows the answer to number 2, so we're going to hold off on Sky. Let's see if anyone else can remember. What is the discriminant? It's part of the quadratic formula. Let's go to Frank. So read it out to me. What is it, Frank?
The discriminant is everything under the answer under the square root.
Sure. So I mean, what are those symbols? It's like b. What's underneath the square root? B. So just what is underneath the square root there, Frank? That's all. Just read it out.
Oh, b squared minus 4 times a times.
There you go. B squared minus 4 times a times c. Is that what you're going to say, Olivia? Good. Good. All right. I mean, I've been asking you guys a lot, so I want to make sure you know it because you can see it's going to show up on our test, right? Okay. So, what does the value of the discriminant tell you about the function? Okay, and we'll draw some sketches to help us explain our answer too here. So, the value of the discriminant. So, in other words, right, if your discriminant is less than 0. Okay, if your discriminant is less than 0, what does that tell us about our solutions? If we have a negative discriminant, right, less than 0, what does that tell us about how many solutions we have? Frank? One answer? No. One solution is an option for one of these, but it's not when it's negative. Go ahead, Sky. No real solutions. Okay, it's actually too imaginary. What the graph looks like in a situation like that is something like this. Okay, you see how it doesn't cross the x-axis? Okay, see how it doesn't cross the x-axis? Okay. Now, Frank, if b squared minus 4ac is equal to 0, how many solutions do we have? One solution. Okay? And that is when the graph of your parabola intersects at a single point and then goes right back up. Okay? Just like that. Okay? So, negative discriminant, b squared minus 4ac is less than 0. That's no real solutions. B squared minus 4ac equals 0, one solution. So then b squared minus 4ac greater than 0 would be how many? 2 solutions. Okay? And that's the situation where the graph looks something like this. Okay? See how the graph has 2 points of intersection with the y or with the x-axis there. Sorry? I'll be posting this to Google Classroom, yes.
Did you post the last one?
The last one failed. Yesterday's died. So
Is that why you didn't post it?
that's why I didn't post it. But I will be posting tonight.
That's how they do on here.
I'm sorry.
That's why it was like today.
I got you. Okay. That's good, right? There we go. All right, so use the discriminate. Whoops. That's a typo. Use the discriminant. Okay, that was probably like an autocorrect or something like that, you know. Word does that too. Use the discriminant to determine the number of real roots for the following equation. Okay, so go ahead, guys. Pick number 4 or number 5. Try it right now. Use the discriminant. Tell me how many solutions there are. Question on your particular one there. So you guys pick. You do 4 or 5. You pick one and just do it real quick here. We'll talk about both. Yep, exactly right. In other words, 196 then was a very square itself. So. Okay, so go ahead, 4 or 5. Do your discriminant there. Okay, come on, take a look. Okay, looks good.
I got it right so far.
Oh, I'm sorry, 4 and 5. Not number 67. 4 or 5. 4 or 5.
Maybe.
Huh?
Can I just plug that equation in?
Graph it and look at the look. You could. That's one way to do it too. So we're not breaking it up. We're using the discriminant, Brady. Okay. So discriminant. Brady. Discriminant. Identify your A, your B, and your C. Plug them in. Okay. Try the camera so you come up with. Okay. So identify your A, your B, and your C, and then plug them in there. Okay. So you're not plugging. Yeah. Yes. Yes. Yeah. Yeah. Good. Exactly right. Yeah. Very good. Yep. Good so far. Aaron, identify your A, your B, your C. All right. Great. And identify those A, B, and C. Good job, Kaylee, so far. Now you're going to take those numbers and plug them into your discriminant there and see whether it's greater than 0, less than 0, or equal to 0. Okay. So you don't need to solve it. Just use the discriminant to tell me how many solutions. You don't need to use the quadratic formula. Just plug it into your discriminant. That's it. Okay. Yeah, Alessandro, you don't need to plug it into the whole quadratic formula there. Just the discriminant is all you got to do here. Okay. Use the discriminant. Can you use the quadratic formula here to answer this? You can, but you don't need to do it. Okay? That's more work than you need to do. Okay, so there are your setups for 4 or 5. And at this point, you can just type the mess in your calculator. Please use parentheses, though. Okay, if you decided to just straight up use the whole quadratic formula, you're welcome to do that. Okay, and that will work, but you don't need to do all that work. Okay, you don't need to because the discriminant alone, we get a positive 148 for this one. Okay, and that's positive, right? It's greater than 0. So that means how many solutions do we have?
2.
We have 2 solutions. Okay, let's look at this one. I guess, look, I can keep pretty much all the same numbers here. Let's see, I just got to change that 3 to a 12. And I got to change that -4 to a 3. Okay, and I get -44. Whoops, off the screen there. -44 is what I get for the second one. -44 is less than 0, so how many solutions? No real solutions. Okay? No real solutions.
You can also just graph it.
Right, so good point. Let's take a look at what Eric said there. Okay, and I think Grayson was asking me about this too. Eric and Grayson both just graphed it. Did you just graph it?
Yeah.
Okay, so you can just graph it here.
That's the easiest thing. Just show it on
Oops,
the graph.
zoom 6. Okay, so there's the graph. I can see 1, 2 solutions where it crosses the x-axis, right? Okay, check the other one. We'll graph that one. And you see it does not cross the x-axis, so there's no
Close.
real solutions. It's close, but no cigar. Okay, so That's another way you can do that too. And that's why I also showed you these little pictures here, right? No real solutions. The graph never crosses the x-axis. One solution, the graph just touches it. And then two, it intersects on both sides. Okay. Number 6, we got a quadratic formula here. Okay. So let's go through this one. All right. For number 6, all right, let me go to somebody here. All right, let's go to Trey. Trey, for quadratic formula, we need to know what A, B, and C are, Trey. So what's our A in number 6? Okay, so just the 5, right? Okay, and then what's our B? Very good, -4. Good, good answer there. And what about the C? -9 is our C. Very good, okay? So quadratic formula, x equals -b, so -4, plus or minus the square root of b squared minus 4 times a, which is 5, times c, which is -9, all over 2 times a, so 2 times 5. Okay? Trey, what is -4? What does that simplify to be? Just 4. Very good. And then I'm going to type this whole discriminant in my calculator here using parentheses. Okay, and we get 196, so it's the square root of 196, over, and then 2 times 5 is 10. Okay, is 196 a perfect square? Yeah. It is, okay? Now, if you ever wanted, if you're not sure, if you're like, I don't know if that's a perfect square or not, let me just show you. All you got to do is do square root 196, just type it in and see, hey, look at that. 14, that's really nice.
You just did 14 times 14.
Yeah. So we get 4 plus or minus 14 over 10. Okay, and so I'm going to break this up into our two solutions here. So we get 4 plus 14 over 10, 4 minus 14 over 10. Okay, what's 4 plus 14? Anybody? 18 over 10, and that'll simplify to then 1.8. Okay, what's 4 minus 14? -10 over 10. What's -10 divided by 10? -1. And so there are our two solutions. Okay? There are our two solutions. By the way here, folks, for these equations, this should really be equal to 0. Okay, that should really be equal to 0 there. Same thing over here for number 7. These should be equal to 0. Okay? It's not really right when we just say f of x equals that, and it's kind of a little bit of bad math there, but oh well. Okay? All right, number 7. I'll run through that one here real quick, too. Let's go to someone for this one, too. Let's go to Alec. Alec, what's our A for number 7? -4. What's our B? 7. What's our C? 5. Okay. So, again, quadratic formula here. X equals -7 plus or minus the square root of 7 squared minus 4 times -4 times 5. All over 2 times -4. Okay, simplify. I'll again type the whole discriminant there in my calculator. Folks, please don't be deceived, okay? We use our calculator for a lot of stuff. But the problem is there's so many different things we do on our calculator that it's easy to forget how to use your calculator to do this stuff. So please, don't get confused there. That's a 129, by the way, in the square root. That's 129. Okay? So please be careful. Okay? Don't take for granted that, I get to use my calculator, this thing's going to be easy. No, not necessarily, right? All right. Square root of 129. Let's see if it's a perfect square. It's not. Okay, can we divide 129 by any perfect squares? Let's see. And let's try 4. Net. Let's try 9. Nope. Let's try 16. Nope. Let's try 25. Nope. Let's try 36. Nope. 49. Nope. I think we can kind of say here that there's no perfect squares that divide it, right? Okay, there aren't any. All right, so.
Oh, wait a second.
You got one?
I got 3. Or wait, no, that's not.
Yeah, not perfect square, unfortunately. Yeah. So, in other words, this does not simplify any further. So we have two answers, -7 plus the square root of 129 over -8. And we have x equals -7 minus the square root of 129, all over negative 8. So there's our two solutions. Doesn't simplify any further. Oops, sorry, blurry.
Not if there was a perfect square.
If there was a perfect square, you would then divide it out, break it up into the two,
Exactly.
and then square root the perfect square and leave what's ever left behind. Okay, and I can show you that more if we have more time at the end.
So if it's a perfect square, do you then square root the perfect square?
Yeah. So just like here, Grayson, where the square root of 196, it's square rooted to exactly 14. So didn't have to worry about that anymore. And then you could continue simplifying.
If that 14 would have been like 25, you break it down even more to be a 5. Like if there's multiple perfect squares.
Right. You'd want to pull out those perfect squares, square root those, and then you'd leave your square what's unsquared behind. All right. So we have a few other little questions here. All right. So we talked about like particle motion and like how things move through the air and stuff like that when they're like hit or kicked or something like that. Okay. So we want to talk about some of these numbers here. Okay. So v sub 0. Whenever you see a sub 0, like a 0 on, like below things a little bit there, that means an initial. So v sub 0 is going to be an initial, or you could also say, or starting. What? What is v going to represent here in these situations? V stands for, what's that? Velocity. Velocity. Okay. So v sub 0, that number in front of the t for these like falling objects or like particle motion problems, that's the initial velocity. What do you think h sub 0 is? Well, it's got that sub 0, so it's an initial, bless you, or a starting. What do you think h represents here? Height. Yeah, height.
I hope this isn't film.
Okay, right? And so this problem, right, we have initial velocity, right? When you hit a baseball, right, it gives you give it some initial velocity, kind of, get going, all right? And then the height of the baseball, also you hit that baseball at some sort of height, okay? Okay. Now we're going to look at some kind of specific things here. When a ball is kicked, what is its initial height? So like think about like a soccer ball, for example. Soccer ball, normally, when you're kicking a soccer ball, where is it located? On the ground, right? So what is the initial height of a soccer ball if you're kicking it from the ground? 0, right? So the initial height of a soccer ball, something like that from the ground, is going to be 0, okay? So just keep that in mind, right? You might need to understand that your initial height's 0 if you're kicking it from the ground, okay? Likewise, when you're dropping an object, like if you hold something out and you let go, what's the initial velocity when you let go? Initially, 0, right? It's got no velocity, okay? For an instant, it's got no velocity, and then it starts to drop. Okay? Don't worry about that upward word. I'm going to cross that out. We don't have to worry about upward. Just what's the initial velocity? It's 0. Okay? So 11 and 12 and 13, we're going to take this particle motion equation here. We're going to fill in some information to write the equation. All right? So we're going to use this right here to fill it in. So we'll say h of t equals, okay, negative 16t squared, okay, and then plus, what's our initial velocity for this situation? A rock falls off a 325-foot cliff. What will be the initial velocity here? How much? What's the initial velocity? If it's just falling, right? It's like dropping the rock, right? Falling and dropping, it's the same thing, pretty much. So what would be the initial velocity? Anna? It's going to be 0. It's 0. So it's plus 0t, right? V sub 0 times t, so 0t. Okay? Plus, what's the initial height here, though? Okay, where does the problem say it starts?
32. Yeah, 325.
Yes, 325. Very good, Brady. Exactly right. So there's your equation. Negative 16t squared plus 0t plus 325. Is it okay if I just put this? Is it okay if I just put this? Are these the same thing?
No.
They are. What's 0 times t? 0, right? So it just goes away, and you'll have the negative 16t squared and the 325. So there it is, right? Okay. All right, what about a golf ball? A golf ball is hit with an upward velocity of 30 feet per second. 30 feet per second. Okay? So again, in number 11, our v sub 0 was 0. Our initial velocity was 0. Our height was 325. Initial height was 325. In 12, okay, what's our initial velocity in 12? What's the starting velocity of the golf ball? Come on, guys, number 12. I know this isn't the most exciting thing, but you do have a test tomorrow, so it might be helpful to tune me in, okay? I know it's like hard sometimes. You don't feel like paying attention. I'm going to start calling on people, I guess. That'll help. Erica, number 12. What's the initial velocity according to our sentence right here? What's the starting velocity?
30 feet.
Yeah, 30 feet per second. Yes, okay, that's our initial velocity, okay? Here's our v sub 0, okay? What's our starting height here? Let's go to Kaylee. Kaylee, what's the starting height? Go ahead, what? Okay, we were not told, right? But where is a golf ball normally? It's on the ground, right? So what would be the starting height? 0. Okay, so yeah, h sub 0 is 0 here. Okay, so again, we're just going to fill in. We'll just fill in our little height here. So h of t equals negative 16t squared plus 30t plus 0 for the h sub 0. Okay, and now we have a quadratic equation that describes the height versus the time. That's just from the, yep, that's just from that formula right there. Okay, the v sub 0, the h sub 0 get plugged in for our particular problem. Okay, we'll have questions like this, yes. Mm-hmm. Is that a good thing or a bad thing, Aaron? A bad thing? Okay. What's the problem? You don't understand where these numbers are coming from? Yeah, sure. Aaron, look, you can be jokey all you want, but if you don't actually tell me what you're having trouble with, I can't help you. So tell me what's up. Are you having trouble coming up with where these numbers are coming from the sentence here? Or are you having trouble putting the numbers in the thing? Or are you having just trouble overall? All of the above. Okay. So let's go through number 13 then here. Okay. So again, what clues us in here, Aaron? So first of all, Aaron, you're going to be given this. You'll have this right here, okay? You'll be given this little formula here for the height of an object that's in free fall, okay? Or, flight, free fall and stuff like that, okay? So you just have to figure out what goes in for your initial velocity and what goes in for your initial height. So right here, Aaron, right, we have a diver that jumps off a 40-foot bridge. So that means what is the diver's starting height? 40 feet, right? If you're off a 40-foot bridge and you're jumping off, your initial height is 40 feet. So there is h sub 0 right there. Okay? The diver jumps off with an upward velocity of 8 feet per second. So then what's our starting velocity? 8. Okay? V sub 0 is 8. So we have h sub 0, we have v sub 0, so we're just going to plug these in here to our equation. So we have the negative 16t squared, right? That's part of it. We'll plug in the 8, bless you, and then we'll plug, and then t, and then for the h sub 0, we're just going to plug in a 40. And there's the equation. Oops, I forgot the h sub t. I'll put it over here. Okay? So now this function will describe the height of our diver at any time t, right? H of t. Height at any time t. Okay? Anything, so these first two, Aaron, I would say they were a little bit harder because they didn't have both numbers written in there. This one was a little bit easier because it very clearly says there's your starting height, there's your velocity, right? With the previous two, you had to read into it a little bit, right? When Kaylee, she was pretty good about getting the velocity there. Or no, Erica was good about getting the velocity, right? But then Kaylee had some trouble because it didn't explicitly say the golf ball's on the ground, but we have to assume that's where the golf ball normally would be. It's on the ground when you hit it, right? So 0. 11, here we're told how high it was, right? 325. We're not told what the initial velocity is. But if it's something that's falling, it's going to start with a velocity of 0 and then pick up speed as it falls. Yes, you can go to the bathroom. Okay. All right. Next then here. Okay, so any questions on 11, 12, and 13 there? All right. You will see questions like this tomorrow. All right. The height of a ball thrown off a building is modeled by this function right here. Okay? How can you determine the initial height? Well, compare this, right, to our formula up here, right? What number is in the place of initial height? 100, right? There is your h sub 0 right there. Okay? So it's the constant term. You could also say c, right? It's the c for our quadratic equation there. It's the c. Okay, so it's 100. Well, it doesn't really say what the units are there. Okay. How can you determine the initial velocity? Okay, well, where do we find the initial velocity here? It's in front of the variable t, right? So what's our initial velocity according to this one? 12. Yes, it's 12. Exactly right. Okay, so it's the coefficient. Slide it this way?
No, other way.
This way?
Yeah.
Sorry, different students have different meanings when they say up. So it's the coefficient of t.
Oh, did I say it the wrong way?
No, you said it the way I, yes, I interpreted it wrong. So in this case, it's 12. Okay, so 12 is your v sub 0 and 100 is your h sub 0, right? That's all there is to it. Okay, we're still talking about the ball here. So 14, 15, 16, 17, and we're missing 18. Oh well. 14, 15, 17, we're missing 16 as well. 14, 15, 17, and 19 are all talking about the same ball right here. Okay? So the next question is, when will the ball reach its highest point? Okay? Well, the ball reaches its highest point. What's that special point called on a quadratic? The highest point of the quadratic is called the vertex. Okay, or you can also call it the maximum, right? But the vertex is a good way to do it too. So we're trying to find the vertex, okay? And since we're trying to find when will the ball reach its highest point, that means we want the time, t, okay? So we're going to use, there's two different ways we can go about doing this. We can use negative b over 2a, okay? How else can we find the vertex of a quadratic? Besides using negative b over 2a, what else could we do? What else could we do? We could graph it, right? We could graph it and then use the maximum command in the calculator. I'm going to show you here with the calculations, and then I'll show it in the calculator too. Okay? So, in our function here, what is b? 12. So it would be negative 12. What's our a? Negative 16. Okay, so we end up with negative 12 over negative 32. Which simplifies to, if I do that division, 0.375. Or if you like to use fractions, you can use 3/8. Your choice there. Okay. We don't really know our time units here. I think it's supposed to be in seconds. Okay. I think it should be in seconds there. Okay. So that's the time when the ball reaches the highest point. But if you don't like having to do that negative b over 2a calculation, feel free to graph this thing. Okay. Just type in to your graph there. See, can I get this all to fit? Yeah, question.
Can you go back up to number 11 real quick?
All right, hang on. Okay, so I'm going to type that function in, graph it. Okay, I got to adjust my window. I got to go up higher, right? So I'll change my y max. Let's change my y max to be like 50. Go to 100. And then I'll go up a little bit more. Let's try 120. So second trace, maximum, go to the left, hit enter, go to the right, hit enter. And there you can see, there's your 0.375, and then there's the actual height, 102.25. So there's your time, though, 0.375. Okay, that's a rounding error on the calculator part there. But you can see it right there, okay? So we can say or graph and use the maximum command. Okay? Now, the beauty of doing that, if we did this on the graphing calculator, we also have the answer to this question. What is the greatest height of that ball? Well, I already got it, didn't I, when I did my maximum? What's the greatest height of the ball here? What's the height of the ball at that highest point? (102.25). Okay, is the answer. 102.25 is the answer. Okay, and I think that's going to be in feet as well. If we don't want to use our graphing calculators, we can take this time of 3/8. Okay, this is the time when it reaches its highest point, and then what can I do to figure out then what the height would be at the highest point? If I have the time when it reaches its highest point, what can I do with that? What can I do with that to then find the actual height at that time? Here's my function. What can I do with that 3/8 of a second to figure out what the height would be at that highest time? Plug it in for t. Exactly right. Exactly right. So we'll do h of 3/8, which will equal then -16 times 3/8 squared plus 12 times 3/8 plus 100. Okay? And then dot, dot, dot. When you simplify it, it will be 102.25 feet. Okay? So you can get it that way too. Your choice how you want to do that there. Okay, I'm changing up pens here because that blue one was bleeding through and I don't want it to make it too yucky, so. Okay, turn the page there when you're ready. The last question we want to ask about this ball is when it's going to hit the ground. Okay, if the ball is hitting the ground, what is its height? 0. So we're going to take our equation here. Okay, we're going to take our equation there, -16t squared plus 12t plus 100, and we're going to set it equal to 0. Okay, we're going to set our height equal to 0 there. Now, how do we solve a quadratic equation when it's equal to 0? What can we use? We can use the calculator and see where the graph does what? If we're trying to see where it equals 0, we want to see where the graph hits the what? The x-axis. Okay, so you can find the zeros of this. What's another way besides the graphing calculator? How else can we solve this quadratic equation when it's equal to 0? Using the what? Hint, it's in the directions up above there. What can we use besides the graphing calculator? What else can we use here? The what? Quadratic formula. Yeah, okay. So A, B, C. Okay, we can do -12 plus or minus the square root of 12 squared minus 4 times A times C all over 2 times A. Okay, so those would be our solutions there. Now it's your choice. You can use quadratic formula, okay, or you can, again, just find the zeros in your graphing calculator here. I'll finish off this piece right here. So we get 144 minus 4 times -16 times 100. Okay, so I get 6,544 there. Okay. So I'll zoom in some there for you. Okay. And that splits into 2 solutions. And now I'm not going to, let's see here. I'm not going to really worry too much about trying to simplify that because I don't think it simplifies nicely. It does not. So we're going to, because this is a word problem, we're just going to go ahead and break this into 2 answers here. So we'll do -12 plus the square root of 6,544 over -32. And we'll do -12 minus the square root of 6,544 over the -32.
Can't you just do plus or minus?
On your calculator, you can't. There's no plus or minus button though, so you have to split up into.
Or for the simplify down.
Will you be posting this in classroom?
I will be posting on the Google Classroom. Yeah.
Wait, no, I mean,
I don't know what you mean, so hang on. Let me finish writing here. Okay. Oops, sorry, I'm off the screen. There we go. Okay. So we simplify that. I get two answers. Do both of these answers make sense in the context? No. Which one should I throw out? The negative one, because why? Yeah, we don't have a negative. We don't have negative time. Okay. So the ball hits the ground at 2.90 seconds. Okay. Now again, if you guys think this is torture right here, then please feel free to graph this. Okay, like I did. Graph this on your graphing calculator, and look, there are your solutions right there, those zeros. So just press second trace and go down to the 0 command. Okay, I'm going to pick this 0 here. Go to the left of your 0, hit enter. Go to the right of your 0, hit enter, and then go in towards that 0. And there it is, 2.90, the same exact answer. Same exact answer here, folks. Okay? You can ignore this one, this 0 over here, right, this 0 right here, because it's negative, right? It's going to be a negative x value. So just use the positive one. Okay, or you can use quadratic formula. Your choice. What's that? Second trace 0. Okay? All right. Now, here's what we did yesterday. So we're like pretty much caught up for the most part. We still have to then worry about the... All right, we gotta go a little bit faster here. All right, so quadratic regression, right? What do I press to do this?
You gotta go stat.
Stat.
Then you do all that. You gotta go to number 5.
Edit. Okay, now I already have this data in, I think. No, I don't. Okay, I got to put it in. All right, so I'm going to clear this. That's right, because I have it in from the homework and stuff. All right, so 0.5, 0.8, 1.1, 1.4. If you guys just want to follow along with me on this one, that's fine. You don't have to like do it on your own because it's going to just take too much time, I think. 316, 321, 324, 323. 320, 313, 296, 264, 204. Okay, check to make sure I did that. Okay, let's see, I got it okay there. So then now that I have my data typed in, what do I press next? Stat.
Right.
Calc.
Then you go 5.
Quad reg, number 5. Okay, calculate that. There it is, okay? You're going to want to round, okay? Please make sure you round those numbers there. So I'm going to write them out here for us. Let's see if I can get it all to fit. So y equals negative 15.9 x squared plus 39.8 x plus 299.5. Okay, there's the equation. Okay, or I should really say, oh shoot. I should use t's here because t is our, we have t for our top column there. So not x's, let's use t's. And then this is h of t. Okay, so h of t equals negative 15.9 t squared plus 29.8 t plus 29.5. Okay. Number 22, if I want to find the height of the object after 1.7 seconds, what should I do with that 1.7? I'm going to tell you there. Go ahead, Alessandro. Olivia, yeah, I'll get it to go. 1 second, Alessandro. Yes, go ahead, Alessandro. Sorry, go ahead, Alessandro. Yes. Okay, yes, 1.7 in for the t. Okay. Okay. Plug in 1.7 for the t, and you get an answer. I'm not going to bother doing that right now just because of time. I'm just going to go ahead and give you what the answer is here because we need to make sure we get everything else in. So, 321, it's approximately 321.21 feet. Okay. Now, what is the initial height? Okay. So, initial means at time what? Times 0. So you could just plug 0 in here. If I plug 0 in here and here, what am I going to end up with? If I plug 0 in here and here, what do I end up with? Yeah, 0 here, 0 here, but what's going to be what quantity is left? 299.5. Yeah, so I get 299.5 is the initial or starting height. And it's the C value, right? It's just the C value. Okay? When will the object reach its greatest height? That means I need to find the what? If I'm trying to find the greatest height, folks, what am I looking to find?
Maximum.
The maximum. Yeah, exactly right. The vertex. Okay? So I'm going to type this mess in my calculator. Okay? There it is typed in. I got to adjust my Y max. So window, Y max, let's change it to 200, see if that helps. Actually, that's probably not going to help. I need to go higher. Yeah, I can see now. I can see my Y values here, like they're in the 300. So I'm going to go up to like 350 and see if that works. Okay, see if that works. Yep. Yes, go ahead. All right, there's my height. So second trace, maximum, go to left, hit enter. Go to the right, hit enter. Top, hit enter. Okay, now I'm being asked, when will the object reach its greatest height? So what is the answer to when will the object reach its greatest height? According to my graphing calculator here, what is the answer to when will it reach the maximum height?
The X.
The X, 1.25. Okay, so time equals 1.25 seconds, we'll say approximately. What is the greatest height? Now I'm looking for which answer here? The Y. So 324.4, we'll say feet. Okay, next question here. When will the object hit the ground? Now I want to see when the graph does what? So for the graph, though, what am I looking at? Where the graph does what? Where it ends, okay, or where it hits what? Where it intersects, yeah, 0, the x-axis, right here. That's where it hits the ground, right? You can imagine it's like kind of like the flight path, almost, in a way, of this object. So anyway, yeah, right down there. So second trace, 0 command. And we'll just go da-da-da-da-da-da-da-da. Make sure you're to the left of the 0 and hit enter. To the right, hit enter. And then back in towards the 0, hit enter. And there it is, about 5.8, we'll say, seconds. Okay. Okay, and again, all these directions, folks, are right here in the question. Okay, all the directions are right there in the question. All right, turn the page. We're on the last page here. When Alessandra comes back, yeah. Okay, last page, folks. Here we go. All right. Here's our garden with the measure, with the uniform width question, and then there's our circle question that we just saw for the warm-up. Okay, so we're going to get through both these right now. Jimmy built an 8 by 12 foot garden. He wants to add a walkway of width x feet around the entire garden. So draw a diagram of the garden with the walkway around it. Label all measurements. So we'll draw the garden here. Okay, 8 by 12. And then I'm going to add the walkway around it. Okay, there's my walkway. And the width is x. So every measure here is x. Okay, every measure here is x. Mary, put that phone away. It's not going to help you. Okay. So, what is the measure of this side right here? From here to here, right? From here to here is 8. What's this going to be? 2x. 2x plus 8. Right. If this is 8, right? This measurement's 8, and I go x this way and x this way, then it's going to be 2x plus 8, right? Or 8 plus 2x, however you like to say it there. And then here, this distance from here to here is 12, but then I'm going to add an x and add an x. 2x plus 12. Very good. Okay. We labeled all the measurements. Ding. Now, 16. Write an equation to represent the area of the walkway only. Walkway only. So in other words, I don't want to have the whole area here. I want to have the area of just this walkway. So I'm going to find the area of the whole big rectangle here, and then I need to do what? Subtract what? The area of this little garden, okay? So, what's the area of the walkway, or sorry, what's the area of the big rectangle here? What would it be? What times what?
8 times 12.
So, not 8 times 12, nope. The big rectangle. Yeah, so 2x plus 8, this side, right, times this side, the 2x plus 12. Then we'll subtract, like you were saying there, Grace, and now we'll subtract the 12 times the 8 for the garden. Okay. Now, this is not really an equation. It's an expression. Okay, that should not be an equation. That should be an expression because it's not equal to anything. Okay, it's not equal to anything. It's not an equation. It's an expression. Okay, so there's our expression. Okay, questions on any of that? Okay. All right, number 17. If there is only 192 square feet available for the walkway, what is the largest possible width of the walkway? So what should I do with this 192? Not plug it in. Set it equal to this. Yeah, exactly. So 2x plus 8 times 2x plus 12 minus 12 times 8 equals 192. Okay, now, how do we solve an equation like this? There's two options that we have. Option one, we can use what? The graphing calculator. Graph this side, find the points of intersection. That's option one. Option two, you have to multiply this out. Okay, so I'll do that here real quick and just show you. You get 4x squared plus 16x plus 24x plus 96. But then 12 times 8 is a minus a 96. So the 96's cancel. And these make 40x equals the 192. And we'll subtract 192 from both sides to make it equal 0. Okay? And then once you get it equal to 0, we can then use what? We could also use what here? What allows us to solve a quadratic equation? Quadratic formula. So you could also use quadratic formula here if you really wanted to. Okay? So it would be negative 40 plus or minus the square root of 40 squared minus 4 times negative 192. All over 2 times 4. And then dot, dot, dot. Okay, I think you guys can simplify from there. Okay. All right. Your choice. Graphing calculator. Okay, you can graph right from here. Graph this left-hand side, graph the right-hand side. Just find the points of intersection. Okay. Either way, when you do that, your answers will be, I worked it out here already. The answers will be 3.54. There's only one answer that works here. Okay, 3.54 feet. And that's a rounding. Rounding it. Okay. Last one. We're going to make it. Yes?
What happens with the 96?
So when you multiply this one out, Lily, great question. When you multiply this out, 8 times 12 gives you a positive 96, but then you're also subtracting a 12 times 8, so they just end up canceling. Okay, in this particular case, Lily, right? It might not be the case for other situations, but in this case it does. Okay? Okay, great question, Lily. All right. All right, last problem. We're almost done. Okay, Emily wants to make a circular cake. The can of icing she bought states it will cover 220 square inches. What is the formula for the area of a circle? There it is, right? A equals pi r squared. I will give you this formula tomorrow for your test, okay? You won't have to worry about that. 19 says replace A in the formula with 220 because that's what the area that icing will cover, right? So 220 equals pi r squared, okay? And then solve for r, right, to find the largest possible radius of the cake. So what do we do here to get the r by itself? What should be my first step? Divide everything by pi. So r squared equals 220 divided by pi. It's about 70, we'll say about 70.0 there. Okay, and then what do we do to finish solving here? Square root both sides. We get r equals the square root of 70, which is 8.4, I'll say. Now, technically, we're in an equation here, and I should put a plus or minus in front of the 8.4, right? But does a negative 8.4 make sense in the context? No, a negative radius does not make sense, so we won't use that. Okay, 8.4 inches. All right, so if the radius is 8.4, what can I do to find the diameter? Double it, yeah, times 2. So diameter is twice the radius, so diameter will be twice 8.4, so it's going to be 16.8 inches. Okay, and there it is. We made it. All right, so let me just talk real quick, and I'll give you enough time. You guys can chill, whatever kind of thing. Okay. So, please look through this tonight. Okay, read through it. It's even got like the directions and stuff like that about what to do. I will post this video to Google Classroom if you need to like re-look at any particular problem. Right? If Grayson, if you have a question, you're like, why do we do this? Go back to the video. Okay, you can look at it. I will also call people in for set tomorrow. Okay, I know that you may not, want to come see me, especially after this, crazy long 80-minute session we had now, but it'll be helpful. So, does anyone want to volunteer to come in for set tomorrow? Any volunteers for set? Because I might just pull some of you anyway. Alessandro, very good. All right, Braden, you got it. I will have tutors in here too, so we'll be able to get you guys some help, besides just me. Lauren, you got it. Hannah T, gotcha. Okay. Any other volunteers? Brady, we got you. Anybody else for a set? Eric, you got it. Any other set requests? Okay, all right. Anybody else? I will be pulling some of you in anyway. Okay. Please come. It is my priority day tomorrow, so I better see you. Uh-oh. Yeah. I don't want to hear any excuses.